Take a moment to read the question. So f is a differentiable function on the closed interval -2, 2, and the value of f of -2 is 1 and f of 2 is 5. It's also given that the absolute value of the derivative of this function in the entire closed interval is less than or equal to 1, and we have to find out the value of f of 0. How do we do this question? Well, first of all, let us note down the values of f of -2 and f of 2, which are the endpoints of the closed interval. Now we can apply the mean value theorem on the interval from -2 to 0, and we get a point C1 which belongs to the interval -2, 0, where the mean value theorem is satisfied. Now from this we get, after putting the values of f of -2, this equation. Now the derivative is always less than or equal to 1, which means we can write down this condition. Now multiplying throughout with 2, we can say that f of 0 minus 1 lies between +2 and -2. Now adding +1 throughout, we can say that f of 0 must be between -1 and 3. Now in the same way, applying the mean value theorem to the interval from 0 to 2, we find that there must be a point C2 belonging to the interval 0, 2, where the mean value theorem is satisfied. And plugging in the value of f of 2, we get this equation. Now once again, the derivative is between +1 and -1, so we get this inequality. Now multiplying throughout with 2, we can say that 5 minus f0 lies between -2 and +2. So therefore, we can subtract 5 throughout and say that f of 0 must lie between 3 and 7. So we now have two estimates of f of 0. Previously we found that f of 0 was between -1 and +3, and now we have found that f of 0 is between 3 and 7. So the only value that is possible and which is compatible with these two inequalities is 3, and therefore f of 0 must be equal to 3. The correct answer is option D. Now, one more way to solve this question would be to consider the line joining the points -2, 1 and 2, 5. So the slope of this line is equal to 5 minus 1 divided by 2 plus 2, which is 4 by 4, which is equal to 1. Therefore, the equation of this line can now be found. It is y minus 1 equals x plus 2, or we can also write it as y equals x plus 3. Now consider the function f of x equals x plus 3. The derivative of this function is equal to 1, and we can verify that this function f of x satisfies all the given conditions of the problem. For this function, f of 0 is equal to 0 plus 3, which is equal to 3, and therefore we can pick option D.